Today by just talking about the structure of the class, showing some videos and pictures of the kind of things that we'll be working on. I want to start out by making sure everybody knows where to find D2L, and because this class is kind of going to run through D2L. So to get to D2L, if you go to the main Normandale webpage, and go to the drop-down menu here, go to current students. It's one of the choices there. And you need a star ID and a password to log in. And once you're in, you'll see a list of all your classes. Okay, and when you finally get into the class D2L site, the first thing you'll see is a list of announcements. And you should get in the habit of checking this. Might as well check it every day, just this is where if there's any new assignments that I'm given or any corrections to solutions or anything you need to know for exams, this is where I'm going to put that stuff. The files will be somewhere else, but this will tell you what's new that you need to know. Later on, when you start turning things in, you can go to your grades here to see how you've been doing on things. And some assignments you'll be submitting through here. But what I want to talk about right now is the syllabus, and that's under content. And there's not too much in here yet, but under course information, the syllabus is here. So I'll pull that up. Okay. So this is Intro to Engineering Design. It's a 4-credit class. And so the first thing I want to talk about is the amount of time you should expect to spend on this class. If you Google, how much time should I spend working on a class outside of class hours? No matter where you find that information, it'll tell you the same thing. No matter what information website you find it on, it'll say you should spend 2 to 3 hours outside of class for every hour you spend in class. Okay. And so this is a 4-credit class. This can get a little confusing here because this is a hybrid class. So we only have 2 hours physically in class per week, but it's a hybrid class. So really it's as if we're spending 4 hours a week in class. Okay. So at the low end of the time expectation, if you do 2 hours outside of class for every hour in class, this should be 4 hours in class plus 8 hours out of class. So a minimum of 12 hours a week you should spend on this class. Okay. So that's quite a bit of time. And I would recommend that you look at your calendar and just make sure that that time is available to, that you can actually block that time out. Because if you can't spend that amount of time on stuff, it's very possible that it's expensive for one thing, and you could end up having a bad experience in this class. If you do spend, I said 12 total hours is what you should consider like the minimum. I really think if you spent 12 hours a week on this class, you would have a great experience, do great in the class. You could think of that as really all it'll take, But just ask yourself, make sure, that you really can spend that amount of time. Okay. My name is Guy Olakin. I have a master's degree in biomedical engineering and a PhD in engineering mechanics, both from the U of Minnesota. Um, please just call me Guyo. Um, I've been teaching at Normandale. This is my 19th fall. Um, and my office is right down the hall over here, S1311. Um, you can contact me through email or phone, but the best way to get a hold of me is through the instant messenger on D2L. So let me pull up D2L again. This is the instant messenger, this little mail icon here. And if you click on that, it's pretty easy to, so I think you have to go to the class list under there and find me and then send a message. But then once we've sent a message back and forth, then it just pops up right away to send messages to me. Um, so class time is 12 to 2 on Mondays. Like I said, this is a hybrid class, so I'm going to be assigning other, videos and readings and things like that in addition to our time in class here. My office hours, I said my office is right down the hall, but I actually do my office hours in the tutoring center upstairs. That's room C2190. Um, and my office hours up there Tuesdays and Thursdays from 1 to 3, and then Fridays from 1 to 2. And if you have any trouble getting to those hours and you'd like to talk, just let me know. I'd be happy to set up meetings outside of those times too. Okay. Um, and the final for this class, I mean, this is way ahead of time, but um, it's the first day of finals week, the Monday from 2 to 4 p.m. Uh, and the only prerequisite for this class is college algebra or the equivalent of that. Um, that makes this sort of a unique class. This is really the one engineering class you can take before you get pretty deeply into the calculus and calc-based physics sequence. So it's kind of a nice chance to see whether you enjoy this kind of thought process. Um, the topics that we're going to cover in this class, this class is pretty different from most engineering classes. It's a pretty self-created class. We're going to work on a few, I guess really two big projects. But we're going to start out by going through the engineering disciplines, and then we're going to get into using CAD software. We're going to be using Fusion 360 as our CAD software. And then we'll learn a bit about circuits and electronics. And we'll learn a little bit about programming. This is a class with just like a little bit of a lot of things. And then the last thing we'll work on is robotics. And you'll design and build your own robots, which is really fun. And yeah. And I will show you videos of all this stuff once we get done with the syllabus. Some of the kinds of projects that people have worked on in the past. The course grading scale is probably going to be 90, 80, 70, 60. Although if there's a reason I need to, I'll relax those grades a little bit. Like if everyone scores lower on an exam than I expected them to, the exam was too hard or whatever, I might relax it a little bit, but I won't make it any harder than that. So like if everybody got over 90% in the class, everyone would get an A in the class no matter what. I'll break the grade for the class down into these categories. So the first one is professionalism. Second one is lecture quizzes, then weekly assignments, then the first big project, that's the design project. Then the second big project, the robotics project, and then exams. And the breakdown is all here. And so I just want to go through each of these individual categories and talk about what these are. This first one, professionalism, consistency, and appropriateness. Engineering is kind of a funny discipline. I feel like it kind of has one foot in like math and physics, which has sort of an informal culture, and then it has its other foot in being sort of a vocational, pre-professional discipline where there are certain behavior requirements, and so I think a lot of times people err too far on the side of having the very informal kind of demeanor coming out of engineering school. And I'd like to just help nudge people towards being ready to work in a professional environment by the time you finish college. And so, it's only 5% of the grade. It's not a make or break thing, but I want to see a focus on attendance and punctuality. And if you can't be here or you can't be here on time, I want you to contact me, and I want to, just have good communication about that. I want you to think about appropriateness in your participation in class. When you turn in assignments, I want you to consider legibility. There are going to be assignments where you're going to turn in handwritten stuff. But I need to be able to read it and follow your thought process. And when I give instructions for assignments, like say I tell you I want something submitted as a PDF, I don't want you to turn it in as a JPEG or something. I want you to, be detail oriented. These are the kind of things that employers are going to want when you start working as an engineer after college is over. Okay. Most people in the class will get 5 out of 5 on that. If you get a lower score than that, I'll try to be very clear about what it was that I think you should try to correct. Then lecture quizzes. Most class meetings, I'm going to start with a 5 or 10 minute, 10-minute quiz. Covering stuff that I've been talking about in class. So it's a way for me to get you to reread your notes. Just try to remember what we've talked about in class. It also is just like a way to get class started on time, because sometimes with this class, it can get where like I'll start saying something and then someone will come in and start saying something again and 2 more people come in. So we're just going to get started right at 12 o'clock with the quiz. And if you miss the quiz, you miss the quiz. I'm not doing retakes for people who just show up late. And then we can jump right into the class after the quiz is over. Well, again, these quizzes are only 5% of your grade, so it's not like a huge deal. Each one is going to be worth 1% of your grade or something like that, but it adds up a little bit. And then every week I'll give you an assignment to do that will likely include some videos to watch. And you will turn those in to the assignment section on D2L. And I'll tell you more about how to do that when I give you your first assignments. These assignments will always be due the next class period. So like I'll give you an assignment today that'll be due next Tuesday. And I would always recommend, if you can, try to get it done before class on Tuesday, but it won't be due until like midnight of that night. So, you have the full rest of the day to finish it. But I think it will make the next class, you'll get more out of the next class if you do the work to sort of solidify the old topics before you come. You know what I mean? Um, so, anyways, try to get as much of the assignment done before the next class as you can. And if you need some extra time, you have some extra time. I will always take late assignments, and I don't mark them off or anything. But if it becomes like a habit, you're turning lots of your assignments in late, then that affects your professionalism score. Um, but there'll be a folder where if you don't get something done on time, you can just turn it into this late folder, and I'll still grade it for full points and everything. There are going to be 2 exams. Oh, that math doesn't add up because the exams are 30%. So I guess each exam will be worth 15% of your grade. And each exam is going to be cumulative. So I guess that it's only relevant for the second exam, but remember that the second exam is going to cover stuff going all the way back to the start of the class, not just since the first exam. And this is the schedule. So the first exam is going to be on Monday, October 12th, and the second exam is going to be on what I gave you as the date of our final, Monday of finals week. And then this is kind of a tentative schedule for what we're going to do each Tuesday in this class. You can see we'll start out by spending a lot of time on Fusion 360 CAD. And then you'll have time to work on the big projects in class. Tells you when the exam is. So anyways, you can look at that. And by the way, this first project, the Fusion 360 project, is going to be an individual project, and the robot one is going to be a team project, a group project. Okay, cheating. So with AI, cheating is a complicated, crazy thing right now. But this is the one class I teach where really you can feel free to use AI as much as you like. It can be really helpful. For example, when you're trying to fix your programming code during the robotics project, AI can be so helpful with wiring or with programming. And so, yeah, I'd encourage you to try to use that, and I'd be happy to help you, try to figure out ways to use it well as you go through. Really, the only time that you can't use AI in this class, I guess, on the weekly assignments, I don't want you to use it. I want you to, because I'm going to be telling you how to do that, and I want you to spend some time trying to think through how to do that. And then obviously you can't use it on the exams, but for the projects, you can feel free to use it as much as you want. Okay. Okay. Does anybody have any questions about the structure of this class? All right. Well, I want to, there's more on here. You can feel free to read through the rest of the syllabus if you want. This is all stuff that the school requires us to put in the syllabus. So there's some helpful information, but I'm not going to read through it. So our first project is going to be a 3D printed project based on a CAD design. And that's the individual project. And then the second project is going to be the robot project. And I just want to show you some of the kinds of things that people have done for these in the past. Okay. That is so weird. Well, let me first show you pictures of um, the CAD design project. So um, once we go through, go through some lessons on how to use CAD and some assignments and everything, everybody is going to come up with, um, is going to design kind of like a product that you make with a 3D printer that would be helpful in your daily life. One of my students made does a lot of crocheting, and she did this holder for crochet hooks and yarn. Um, it's a video. Oh, so okay, that's that's one. Somebody created a jewelry stand. And a lot of the grade for these projects is going to be based on, you're going to have to turn in a report also, and your report is going to have to like detail the thought process. Why did you make this decision? Why did you make this decision? Why was this? Start this again. Uh, why did you choose these indents to be this depth? Why did you choose them to be this width? I just, this design process, I want to be very deliberate, and I want to hear really good explanations of why you made each design decision. Wire organizer. I don't even remember this one. Oh, yeah. Okay. So this is a for a for like earphone cables and stuff. This was just kind of a unique approach to designing a thing that holds the cable. I'm not sure if it works better than anything else, but um, this is something that breaks down into a very small amount of space and then expands into this shape when you want to wrap the wire, and it's pretty unique looking and stuff. So that'll be the first project. Just uh, those are three of the many that I've gotten from students. And then the second project is going to be the robot project. So let me show you some of the robots that I've seen. I used to teach this class a long, long time ago. Uh, so first, let me show you the video from 2009 of people showing off their robots. And then I'll show you some more recent ones. So this was a card shuffler, uh, all made out of whatever that is, erector set, Lego type things. Um, but the the basic idea of any robot is it has a sensor or sensors uh, that measure the environment, and then based on what that sensor tells you, it does some kind of motion. So um, there's a light sensor down here. Where is it? I guess over here there's a light sensor, um, and the cards are held, a deck of cards is held here. And that light sensor is always just looking, are the cards there or not? If there are cards there, it can't see any light. Once the cards are gone, it can see light. So once this light is visible here, it stops shooting these cards over to the other side. It knows that it's done. It dumps those back in and does it again. Sort of a simple idea, physically sort of a, easy execution, but there are always a lot of details into making something work well. So you can see it, all the cards were gone, and so it dumps it back into the other side and does it again. This one was just a simple like drawbridge. It used some kind of sensor to determine if there was a vehicle at the gate of that bridge, and if there was, then it lifts up the bridge. That kid was not in the class. I think this thing just searches out an obstacle or whatever, and people do these things like this one of two ways. You either avoid obstacles or you try to aim at a target. I think this one is aiming at that target, but it's just moving around, hopping around, scanning until it sees the target that it's trying to get to, and then it goes in that direction and repeats. So it scans, it's like, okay, there's where it is, so it goes towards it. Oh yeah, this was the one that I really thought there were going to be some bad injuries from this one. That's a refrigerator that they, bought at a garage sale or something, cut a hole out of the door. And I can't remember how you activate it. I think maybe there was a button activation, but like you press this button and it launches cans of like soda cans at the person. It was kind of terrifying. And then this was a card shuffler. I mean, a card dealer. I think it just dealt blackjack. Their original plan was to do a bunch of different games that you could choose, but okay. So those are some old ones. And now let me do some newer ones. Okay, this one was like, you could think of it as like lab equipment. It measured the coefficient of friction between two surfaces. So it's measuring the coefficient of friction between this block and the wooden wheels that are spinning. And it's doing it with force sensors that are attached. So it's just measuring the weight force, and at the same time that it's measuring the backwards force. And then it's printing out those results. It's waiting until it gets like a consistent reading calculation, and then it prints it out onto the screen. This one, I think it had lemonade and iced tea, and you could choose whether you wanted a glass of lemonade or a glass of iced tea or a glass of Arnie Palmer with them mixed. And it had some just nice features like um, it had this readout that you'll see, like it tells you what it's doing after you press the button. It has these things so it won't pour any liquids if there's no glass in there. They definitely could have spent a little more time making the interface look nice, but and you can see it reads out here. Uh, this one was a simple one. It's pretty easy to like online find instructions for making something like this. It just follows a black line, I think, on the ground. Um, but they did some things really nicely. This is a 3D printed chassis that they did really well, and they also used a mill for printing circuit boards to do their electronics. Some of their electronics made the electronics look nice and clean. This video makes you dizzy. It doesn't even show it doing it. Well, it did it. Uh, this one, I guess this is the last one I have. This one, they had water pumping from one tank to another tank, and they had a sensor on it to detect whether water was leaking as that happened. And if the leak was detected, then it would shut off the pump so that you didn't end up with like a ton of water on the floor. I mean, you could imagine that being a useful thing. So I think, yeah. So the pump is going at the start, and then they open this valve to simulate a leak, and the moisture detector uh, then reads a certain value and turns off the pump, so you don't end up with water everywhere. Okay, so that's the kind of stuff that we'll be working towards in this class. Um, it's a it's a fun class because you have a lot of freedom for creativity. You can make things that are actually useful for you that you've been curious about, um, and yeah, it's sort of a lot of it is kind of self defined. Anybody have any questions about the class? Okay. Um, so I guess the first thing that we are going to do is just get signed up for Fusion 360. Um, how many people here have a laptop with you? Anybody? Okay, that's helpful. How many people need to borrow a laptop? One. Oh, not many. Okay, well, actually, if it's less than one per table, you might as well just use the desktop there. Um, and we're just going to get signed into this CAD program. So yeah, get your laptops out, or else log into. If you don't have one, you can just log into that desktop there. And when you get logged in, here's what I want you to do. So this is Fusion 360 registration. So first, go to HTTPS and then www.autodesk.com. /education. Slash edu hyphen software slash overview. Okay, so I think that is the website you need to go to. And then you'll click I think it says sign in, and you have to use your Normandale or some school issued email for this. Then it'll ask you to verify your educational eligibility, so you'll have to enter some information about yourself. Yes.
We have to press create an account because it says I can't find the account.
Oh yeah, yeah. So you did sign in and it said couldn't find your account. Okay, yes. What does it say? Create account.
Yeah.
That sounds more plausible, doesn't it?
Yeah.
Go to create account. What you want to do is go to, you can like Google Fusion Online, or it's fusion.online.autodesk, and then launch Fusion. And sometimes you have to do a couple of times in order for it to launch, but these percentages will start coming up, and eventually it'll let you into this CAD environment. one nice thing about this software is it has a fully online environment. So you can use your account from any computer. But if you're always going to be using the same laptop, I think I would recommend downloading it and installing it on your computer. It's a sort of a better experience. Yep. Who designs? Yeah. Yep. Okay. Yeah, let's just leave this on. I don't think it matters, but yeah. Now you can just close and then now you're in it. So now you can go and close that file. And now go to, let's just try going to Fusion. Fusion.online.autodesk. Yeah, I guess what you know. Okay, so I think we're not going to do anything with this today, but if you can get to this, then you are ready to go for the next time we do it. If you can't get to this, then it might as so I guess I should talk to you individually about what it says is going wrong. But anybody who has gotten to this point, that's it for class for today. So you can pack up and go. Anybody who still needs help getting this, stay here and I'll get that figured out. And by like later this afternoon, I don't know, maybe by 3 o'clock or something, look on D2L and I'll give you the assignment for this week. Okay. All right. Thank you.